One of the reasons that the students are here, we only have the space for them to be in the room, but our own Professor Otiano is also their faculty sponsor, their whatever you want to call them. We just call you our IT dude. And, but anyway, so why don't you take it away and show us the robot. So,
okay,
thanks so much, Eric.
Awesome. Listen, thank you very much for coming. I know everybody's busy, but you're taking the time, so I appreciate that very much. What I want to do actually is to turn it over to the students. They'll give you a quick overview of what the club is about, what we have done.
And thank you also to DeVry for giving us the workspace. We could never have done it without your workspace. Thank you so much.
I'm going to start out by talking about FRC, which is the first robotics competition. It's really what we're doing the whole robot for. It's a national and annual competition for high schools across the nation. It actually includes a few international teams, so that's what we're included in. It starts out with a 6-week build period for each team. That's early January to February. And after that period, you have to bag up your robot, which is look at our workshop, we have our first robot bagged up, and we're not allowed to touch it until competition time, so they have to go over it. So we only get the 6-week period. And what FRC really does is it focuses on STEM, which is science, technology, engineering, and math, because those are the biggest industries. They're growing more rapidly than any other industries. We're trying to get more high school students involved in it. And we also, another cool thing about FRC is that it's very collaborative, meaning we actually, though we're competing against other high schools, we're also working together with them. For example, before we had this workshop and all the resources, Walden and Kell High Schools over in Marietta actually let us use their facilities and their resources, and we could prototype before we even got to start on our own. And even though we're going to be competing against them, it's very friendly and we'll still be working together in the future.
Yeah.
So a little bit about Pisgah Robotics in particular. We are a brand new team. The idea for Pisgah Robotics was first conceived in October of 2012. And we actually did not have our first meeting until January 5th, which was the day we all got on the bus and went down to Georgia Tech to learn what the game would be this year and to start our 6-week build period. Since then, we've grown. We now have 22 members who come to help out with all the different aspects of the robot, and I'll introduce you to them in a minute. But one thing that Professor Tanner mentioned that's very unique about Pisgah Robotics is that they've opened up to the homeschool community. As a homeschooler, a lot of times, I can find all those great academic challenges at home via online classes, but the clubs and things that my fellow students in school get to participate in, a lot of times I miss out on. So I really appreciate, and I know other students like me too as well, that Pisgah Robotics has opened their doors to us and allowed us to participate. So now we would like to introduce some of the main players from our team.
To start out, one of our smallest sides of our robot, but also probably one of the smartest, is our programming team. So if they will stand up, stand forward.
Here's our engineering team, which does the mechanical and everything. So they'll come forward.
And the third one is electronics. The electronics team, which also includes some of the pneumatics too, so if you guys would stand up.
And we'd like to extend a super special thank you to all of the adult mentors who would come night after night, even when their children couldn't make it, to help us out. They're scattered around the rooms right now, but they have been so essential to this team, so we really want to thank them. We're going to demonstrate the robot now, and then after that, we will be spaced out around the room. If you want to come ask us any questions, anything like that, we can help you out with. And finally, we would like to say a huge thank you to DeVry, because we could not have built it if we didn't have this
Before you start to demonstrate, on behalf of DeVry, I wanted to pass out just a little something extra to show how much we are excited about your, even though you're new, doing the very best you can. So We hope you
so much.
really, well, you have to raise your hands, whoever the students are, because I get confused.
Well, what are you going to demonstrate?
Movements of the robot, how it moves, how it turns, how different things work, and like we'll just show them how it works in action, and what it looks like, what it's doing.
Okay.
And so it shoots.
Okay. All
So
right.
we'll take it outside.
Would you explain what the goal is?
Okay. Isaac, would you
Okay,
explain
so,
the goal? If you explain that.
So this year's game, the name is called Ultimate Ascent. It's basically we have a robot. There's alliances of 3 teams each, and each robot can have a maximum of 4 frisbees in the robot. The goal of the game is basically to take robots and shoot them into goals that are spread on opposite sides of the field. In the middle of the field, there are also 2 pyramid goals, but those are extremely difficult to get, so we just go on that plan. Our robot is a shooter, as you can see. There is a loading dock, and there's frisbees strewed across the floor of the field. So the robot can either pick up the frisbees, or they can go to the loading dock and put the frisbees into their robot, which is what we decided to do. And the basic concept of a robot is basically, we put the frisbees in a loading dock, we go over, shoot, and win. That's
Just very briefly, Matthew, can you step forward and talk about your opponent?
Oh yeah, in the first 15 seconds of the game, you get to have an autonomous period where the robot does work solely by code, and you cannot control it. So you have to, the programmers have to program 15 seconds to shoot a maximum of 3 frisbees into the goals, or you can decide not to shoot them depending on what you want. And during that autonomous time, you get twice as many points. So it's pretty important.
And we have.
For those of you who have not been at any of the competitions, if you can tell me if I'm wrong, each team gets the exact same kit with a set of instructions, and each team determines by the individuals how they want to make their robot, how they want to construct their robot. So when you go to the competition, you'll see robots that don't look anything like each other, because it's the ingenuity and the design of the students that makes each robot what it is. So it's really very, very fascinating. So if you have an opportunity to attend, and absolutely to see our winners here, so you should do that.
There you go. Like that. So I think there are two aspects to this. One, you will see basically the robot maneuvers in this room. When it comes to demonstrating the shooting, I think we want to do that outside. So we don't. I think we want to do that.
back looks like it's a nice American flag. And basically just to turn, we have joysticks, so we have to reverse the turn. If you look carefully in the front 2 wheels, we have omni wheels, which means they can go in many directions, while the back wheels are just take wheels, so that when we take those wheels, when people try to push our robot, we have 2 back wheels that are set firmly in place so that we can't be pushed. Because if we had 4 omni wheels, other robots with more powerful drivetrains could easily push us around. And basically just driving around.
So are you trying to hit your robot at this competition? It's like one big demolition derby? Of teenage boys?
Would you mind standing around the robot so we can get kind of a photo off?
Okay.
That's great.
The back.
All right.
Unbelievable.
just won Movie of the Year. Yay! I said I'm going to do another one. But thanks. Yeah.
President.
Yeah.
There you go.
A clash among all these red shirts.
Wait a minute, we can't sing up together.
Yeah, there you go.
How much pressure is it having when it comes out?
If you give your card, will you send us a shots?